how have you received the news that you've been awarded the BBVA Foundation Frontiers Award? How does it feel to you personally?
I was very surprised. I had not known that I'd been nominated for the award. And of course, it's a great honor, and I feel very privileged to receive the award.
What was the basis for your prediction that chips would integrate millions of components?
The basic physics of semiconductors limit how small you can make a transistor. In 1971, when I was working on the scaling of transistors to smaller sizes, people thought that the smallest transistor you could make was around 10 microns in linear dimension. When I worked out the basic physics, it turns out that nothing limited you until you got near 1/10 of a micron. So at that time, I was quite confident that we would be able to make 10,000 times more transistors per unit area than we were doing, and that would lead to very complex chips which would revolutionize electronics.
And how was that prediction perceived at that moment?
At that time, people did not believe that you could make transistors that small, and they didn't believe that you could get that many of them on a single chip. But I was fortunate to have an ally in Gordon Moore, who had already seen a trend where the complexity of chips was doubling every couple of years. So the two of us were allies in a campaign to convince people that this was going to happen.
Did you ever imagine that research could revolutionize our everyday lives?
Back in 1970 and 71, we were still dealing with very simple electronics, but it became very clear to me that we would be able to make complex enough circuits, small enough and cheap enough, and use small enough power that it would go into everything that we touch. I actually made that prediction at that time, that it would really revolutionize what our everyday lives are about, and of course that's come about.
Why did you change the topic of your research from switch to neurological systems?
When you think about the way computation is done, and you think about the chips getting more and more complex, you look for analogies with systems that are complex and do computation. And the brains of animals are a beautiful example of very complex systems that do very delicate and efficient computation. It became clear to me that we had a lot to learn from the computation that goes on in the brains of animals. And I spent about 15 years trying to figure that out.